Welcome to our next video on ratios. In the past videos, we've noticed how ratios are similar to fractions, how they create a comparison between two numbers, share an order, and can be simplified. But in this video, we're going to learn about a superpower of ratios. Ratios can do things that even fractions can't do. In this case, one of the most important things ratios can do that fractions can't do is compare three quantities. So now we're going to look at ratios that are a number to a number to another number. They're going to show a relationship between three quantities. We're going to see what stays the same and what changes when we make ratios like this. So let's use a ratio to compare three quantities. In this case, we have squares, triangles, and circles. There are 12 squares, 6 triangles, and 4 circles. So the ratio of the number of squares to the number of triangles to the number of circles is 12 to 6 to 3. I want you to notice how I needed to say the names of all three quantities in the same order as the names of all three numbers. Order still matters even when we compare three quantities in a ratio. Now, you can actually simplify even if you have three quantities. In this case, we're always looking for equal groups. Notice how we can put the 12 squares in 6 equal groups of 2. We can put the 6 triangles in 3 equal groups of 2. And we can divide those 4 squares into 2 equal groups of 2. When we're doing equal grouping, we're either thinking through our times tables or using division to find equal groups. So the ratio of the number of squares to the number of triangles to the number of circles is 6 to 3 to 2. Okay? Remember that TO2 between each of our quantities is represented by a colon, one dot over another. Now, Sam has been working on ratio problems and he has an answer that he wants us to check. I want you to notice in the picture that we see 2 pants, 3 hats, and 4 shirts. So Sam concludes the ratio of the number of shirts to the number of hats to the number of pants is 2 to 3 to 4. Is Sam correct? Let's look at that. You might have noticed something I was doing with my hand as I was counting. I was noticing that when he said the words, he first said the shirts, which are on the right side, then the hats in the middle, and then the pants on the left. But when he counted the 2 pairs of pants on the left, then the hats in the middle, then the shirts on the right. Remember that order always matters in a ratio. It doesn't matter if we're comparing 2 quantities or 3 quantities. So if we want to talk about the ratio of 2 to 3 to 4, that's the ratio of pants to hats to shirts, which is not the same ratio as that of shirts to hats to pants, which would be the ratio 4 to 3 to 2. So order matters. In this case, Sam got that one wrong. He did the order opposite, so the ratio was not correct. Now we're going to look at a ratio with no pictures to help us. We need to write the ratio 18 to 6 to 30 in simplest form. Remember that when we're writing it in simplest form, we're trying to divide it by the greatest common factor. We need to divide every single term in the ratio by the same factor. So my little hint, my little trick with this, when I'm looking for the greatest common factor of 3 terms, I start with the smallest number. Why? Because smaller numbers tend to have a smaller number of factors, okay? So let's look at 6, and we can use the rainbow method to find the factors of 6. 1 times 6 is 6, and 2 times 3 is 6. Because I work from outside to inside, finding the factors in the different multiplication problems that have the product of 6, I know when I found all the factors. So the factors I have are 1, 2, 3, and 6. Dividing by 1 won't do us any good. It will leave the numbers the same. I want to start with the greatest factor and see if it's in common with each of the 3. Is 6 a factor of 18? Yes, 6 times 3 is 18. Is 6 a factor of 30? Yes, 6 times 5 is 30. So the ratio 18 to 6 to 30 in its simplest form is 3 to 1 to 5. Okay? I did that by looking at the 6 times table. I started with the smallest number, found all of its factors, and looked from the biggest to the smallest to see if one of those factors was in common with all the terms of the ratio. remember that you can write this out to make it simpler. So what I would do is start writing out all the factors of 6, and then I would check each of them against the numbers 18 to 30. So a common factor of all of those is 6. Divide all 3 of those numbers by 6, and you'll get what I just mentioned. Now let's look at the ratio of 15 to 24 to 18 in the simplest form. Once again, let's start with the smallest number, which is 15. And let's do the rainbow method to find the factors of 15. 1 times 15 and 3 times 5. Because we've done the rainbow method working outside to in, we know we finished finding all the factors. So the factors of 15 are 1, 3, 5, and 15. Let's start from the biggest one, working down to the bottom to see if we can divide. Is 15 a factor of 24 and 18? No. All multiples of 15 have to end in 5 or 0, so I know that one's not going to work. Next, I'm going to look at 5. Is 5 a factor of 24 or 18? Nope. All multiples of 5 also have to end in 0 and 5, so that one's not going to work. Let's go to 3. Is 3 a factor of 24 and 18? Yes, I've seen the 24 and 18 on the 3 times tables, so let's look at how we can divide. Divide all of those numbers by 3, and we get 15 divided by 3 is 5, 24 divided by 3 is 8, 18 divided by 3 is 6. Remember, you can place these ratios one on top of the other to show the process of dividing it by 3 if that's going to help you. You need to write out your work in order to solve ratios. Those who have faster multiplication tables and better skills with factors will have an easier time simplifying complicated ratios. So that's our video for today. Today I wanted you to learn that ratios have a superpower that fractions just don't have. Where fractions can only compare 2 quantities, ratios can compare 3 quantities, or even more. But even though we're comparing 3 quantities and the ratio looks a little bit different, it still functions just like a ratio with 2 terms. The order matters, and you can simplify by dividing by the greatest common factor. Thanks again.